Hi everyone, and welcome to my talk, How to Write Gradle Plugins. Um, 1 second. In Kotlin. Um, why it's important to write it in Kotlin? Because, well, we write everything in Kotlin. Even our build Gradle files will be written in Kotlin. What do we do today? I've prepared a Gradle plugin, which I will use as an example to show you how I've written that plugin, and which helps you to understand what is needed and which components are used to do so by yourself. But let's introduce myself first. My name is Stefan May. I'm from Germany. I'm an Android developer since July 2014. I'm currently working at Grandcentrix. It's a company based in Cologne, but I'm working completely remotely there from a small city near from Frankfurt am Main, which is also in Germany. If you have any questions or get social with me, you can find me at Twitter or at GitHub. I also tend to write blog posts. You can find me at Medium. And if you're really interested in the Kotlin DSL from Gradle, I've written a super useful blog post at Medium, so check it out. That's my agenda for today. First, I say you why I do that talk, why I'm so crazy and go on stage and explain everything to you. The next thing is I will introduce you to the project, which I will use as an example. It's basically just a Gradle plugin, which will help you to read lines of codes from given file paths. And finally, I will demonstrate you how I've written that plugin. So let's start with why. As I already mentioned it, I'm an Android developer since July 2014. Back then, Android Studio wasn't stable yet. We have used Eclipse and the Eclipse plugin to develop. Later that year, in December 2014, the Android Studio and the Gradle plugin got stable. And back then, I said to myself, OK, Gradle, what is Gradle? I haven't really cared about it. I know that Gradle is a new build system for Android, but back then, I even don't know what a build system is, or even that such a thing like a build system exists yet. But well, I have to deal with that, and most of the time I just copy and paste stuff from Stack Overflow. I don't know if you are familiar with that, but the most common thing is maybe to get the Git hash and put it to the build configuration to display the latest version into the settings of the app or something like that. Then the rise of the build variants and the product flavor starts. It was even common to start to create product flavors, even if you don't have real product flavors. The simple example here is that you may have a developer variant to customize some things of your app, for example, the launcher icon, or have hidden settings, developer settings inside your app for such things. But my really interest into Gradle was I started with a mate from my team to create the Android library, and we wanted to publish it at a JCenter, and we don't know how to do that. And we find a really helpful plugin for us, which really needs just a few lines of code to apply that plugin and publish that library to Bintrade JCenter. And that was the time I really said, OK, what is Gradle? What is it? How does it work? And can I even write a plugin for myself? The next thing, I want to introduce the example project. As I already mentioned it, it reads just the lines of code for given file paths of directories. How does it look like? Well, first, we apply our plugin. Don't get confused with the plugins block here. I don't know if you're familiar with that, but it's just thinking about that it's a replacement for the build script block. You all know that we have a build Gradle file inside the top root directory from our Android projects. And yeah, more or less this plugin is a replacement for that, and it's way easier to use. That is Gradle Kotlin DSL. So that is completely written in Kotlin and has nothing to do with the groovy version we use back. But to mention here as well, the plugins block has nothing to do with the Kotlin DSL. You can use that in the groovy version as well. Yeah, back to my plugin. It brings a block with it, the Glock block, and has two properties. The enable properties, which is just a boolean that you can say, okay, is it enabled or disabled and behave differently. And the dears property, which is an array of file paths where we want to read these lines of code. The plugin brings also a task within. It's the name of the task is Glock as well. And how that behaves we will see on the following slides. So if we run our task for the first time, we say just Gradle wrapper, just please run my Glock task. It prints hello plugin, and the task will run, and it's create an output file at a given folder in the build directory somewhere with the lines of codes. If we run the task for the second time, and our input and our output haven't changed, it's not needed to run the task again, so it should be up to date. The next thing is, if we run our task with build cache enabled, I don't know if you know what the Gradle build cache is, but just thinking about it's a cache in the Gradle home directory, and it's totally separated from the project, from your currently Gradle project. For the first time we run the task with build cache enabled, it should be succeeded, the task should be executed, and we have the output, the generated output. And if we run it for the second time, even with clean, which means the build directory in the project got removed or got cleaned, we use the build cache, and it should say, okay, the output is still in the cache somewhere, and we can use that. We don't have to run the task again. And how our output look like? Well, as I said, it's just read the lines of code. And this time it prints just the directories. We have put it in the main and the test source path. And this example says, okay, in the main directory, recursively has only Kotlin files with, in sum, 145 lines of code. So, how I've written that plugin? Well, start with a hierarchy. There is nothing special. There's really the same like we have to in Android projects, for example. First, we started with the Gradle boilerplate files, I will say. We have the wrapper files, we have the Gradle directory where the wrapper is defined. And, well, we want to write our Gradle plugin with Gradle. So we have the build Gradle file and the settings Gradle file. And as I said, we use Kotlin in our Gradle files as well. We have to use the extension KTS there. And where's the source located? Well, just in the main source set, and our test in the test source set. So, how our build Gradle Kotlin file look like? We apply a few plugins. The first plugin is the Kotlin plugin. There's no special here beside of the Kotlin method, but don't get confused here. It's just an extension function from the Kotlin DSL, which maps to id org jetbrains.kotlin minus, and then what you put in as a string. So you can even write id org jetbrains kotlin minus JVM and put a version, it's completely the same. So it's just a shortcut. The next thing is the Java Gradle plugin. The Java Gradle plugin is his name is defined by Gradle as the Gradle plugin for Gradle developers. So it's a little bit confusing, but it's really interesting, really helpful to write the plugins. So we want to take a deeper look in it. It does more or less three things. Firstly, it applies the Java plugin, which we don't want, but it does it for us because we want to write in Kotlin. The next thing is it applies the Gradle API dependency to the compile source set. That means it brings all the Gradle APIs to our project. To mention here is that it brings also the internal APIs to the project, so we have access to it. But really, it's not recommended everywhere, of course, to use that internal APIs. I know there is an issue open at Gradle that they want to split it up, but currently it is not. And I'm a testing lover. It's good that the plugin will also apply the Gradle test kit dependency to the test compile configuration, which brings us a really cool class to test our Gradle plugin. Yes, and the next plugin, it's more or less just for manual testing. It's not really needed for write a Gradle plugin, but it's for manual testing. The Maven Publish plugin, which helps us to easily push our plugin to the Maven local repository, and then we can consume it later in this project or in another project. The next thing is, well, you are familiar with it. The repository is JCenter. We apply the standard lib of Kotlin. It's the same here with the Kotlin file. It's just an extension function to remove some boilerplate code. For testing, we used assertj to do some assertion of, and JUnit 5. To mention here, to test our Gradle plugin, it's not needed to use JUnit 5. You can even use any framework, test framework you like. You can even use Spock, for example. Gradle wanted to use Spock. In the documentation, they say use Spock because they do it heavily and it's worked very well with Groovy, but we don't want to make Groovy because Groovy is a little bit crazy. So yeah, I just choose JUnit 5. And to the test thing, since Gradle 4.6 and up, JUnit is directly built into Gradle, and you just have to find the test task and call the method use JUnit platform, and everything is done. You can use JUnit 5. The group and the version string is also just for the Maven Publish plugin, so for manual testing. And the next thing is really interesting, the Gradle plugin. It came from the Java Gradle plugin, development plugin. There you define a plugin and the ID and the implementation class. The ID is that thing which you use in the plugins block, and yeah, it's just a name, so you can literally use every name you like, but it's common or it's recommended from Gradle to use your package name that Gradle knows, or a user which uses a plugin from where it does it come from. So back then, Gradle started with the Java plugin. They just use Java, but they started to use org Gradle Java because everyone who takes a look in that build Gradle file, they know, okay, that's a core plugin from Gradle themselves. And the next thing is the implementation class, which points to that entry point to our real plugin implementation. So Gradle knows if a build script apply our plugin, it knows, okay, I will call that method inside that class. How that class look like? Well, it's just a plain Kotlin class which implements the plugin interface and a generic, this time project. Why it's a generic? You can also write settings plugins. So it's for the settings file. I want to focus on project because it's way more common to write Gradle plugins for a project and not for the settings file. This plugin interface composes just one method, the apply method, and that got called, if the plugin got applied. To notice here, the class is open. Why is it? Gradle, I don't know why, but Gradle create proxy classes of all your stuff you do. So we will take later a look at extensions and the task, and this has to be open as well, because Gradle do some magic behind the scenes, and therefore it's not allowed to have final classes. And that's the reason why it's open, and it's not allowed to use final classes here. Testing. As I already mentioned, I'm a testing fan. The Gradle Runner is a really cool class which helps us to create functional testing for the plugin under development. That have nothing to do with pure JUnit tests. That's a completely different thing. But with the Gradle Runner, you can actually test your plugin, how a consumer does it. So it has some method to call. The first thing is, you have to grab an instance from it with a create method. And the next thing is we have to define the project directory, just a temporary directory somewhere where you create your test. The next very important part is the with plugin class path method, because you have to imagine that the test and the plugin under test runs in completely different environments. So if you don't call that method, your test don't nothing about your plugin. So if you want to apply that in your test, you have to call with plugin class path with just inject the plugin under test into the test environment, and you can test it. The with arguments method receive a var arg of strings, and that is just what you call when you call the Gradle wrapper. So in this example, if you call just the task, which prints out the graph which tasks are available in that project. And finally, you can build the test, which returns a build result where you can make assertions on it. You can also call build and fail if you expect that the Gradle plugin will fail. However, why? So how does a test look like? Well, just we create a file, a build Gradle file in a temp directory somewhere, apply our plugin, then we call the Gradle Runner with a project here, with the plugin class path, with which will inject the plugin into our test environment. Well, and then we can say if the build result output, which is everything which will Gradle prints if you run a task, should contain hello plugin. And that works. But we wanted to have that glog block in the build Gradle file, and that's the next thing we take a look on. Well, the funny part is it's just an object with some properties in it. There's really no magic behind that. As you see here, it's a glog extension, and it just has these two properties. We want to define the enabled and the dirs with some default properties, and that's all. As I already said, open, because Gradle does proxy class of that. But that's not all. We have to register that extensions to Gradle. How we do that? Well, back to our apply method, we can call project extensions, which will return an extension container. And there we can call create with as a first parameter a name of the extension. It's more or less the root. And the second parameter is the type of the extension. So, which means that creates the Glock extension for our plugin. Well, we want to behave differently on the enabled state of that extension. How to do that? We can, or we could, simply say, okay, if the extension enabled plugin, we want to print line something. But the problem is, the apply plugin got directly called if we apply the plugin. And that's way too early, and the enabled state has always the default value. You have to imagine the following. Gradle reads your build Gradle file from top to bottom. And if it say, okay, apply that plugin, it calls the apply method. Then we create our extension. And then, well, nothing more. And if we then want to access the enabled state, it's still the default value. So we have to put it into the after evaluate listener, which means Gradle reads the stuff, the applied plugins, call the method apply, we create that extension, then it goes down the tree, see our extension, it set up all the properties we have defined in our build Gradle file, and then, if everything finished, Gradle is ready to run, then the after evaluate listener got called, and then we can behave differently. And this time, if enabled is to set to false, we don't want to print line, and if it's true, well, we want to print hello plugin. How a test look like? As well as before, we create our build Gradle file in the temp directory somewhere. This time, we can use the Glock extension with as enabled false. We set up the Gradle runner with a project dir and the plugin class path. And finally, want to assert that the output does not contain hello plugin. As well, another test, if we say enable true, it should contain hello plugin. So, to recap, what can we do so far? It's already possible to apply our plugin, and we have that pretty cool Glock extension with these two properties. But, of course, we want to do more. We want to create the read the lines of code task. So, how we do that? Well, we can just create another class, the Glock task, which should extend from the default task, which brings just a few properties we can do. We have to access to then, but we don't have to override anything. We are completely free to define any functions. To say Gradle, okay, where's the action in that task? We just have to use the task action annotation and put it to any method you like. So in this time, it's a fun action, and the name is action, but you can name it like ever you want. You can name it, read lines of code or whatever. You can even, if you like, apply multiple methods with that annotation, and everything will run synchronously. So, that's from the task side. We have to, as well as the extension, register that task, this time at the task container. So we say project task create, this time with 3 parameters, the name of the task, the type of the task, and the last thing is a configuration extension. The it is the Glock tasks themselves, but resolved. We say here group and description, which helps the user if they run Gradle task, which prints all the available tasks for that project, to find it there. So the group is if needed, Gradle will create a new group with the name development, and the description gets the lines of code for files. And when you then run Gradle task, your task will be available there. So how to test that the task is available and do some stuff? As well before, we create the build Gradle file, apply the plugin, enable the default value true, so we don't have to do anything here with the Glock block. Create the Gradle runner, this time with arguments Glock, which is our task. And then we assert assert on that the output contains hello from task, and the task log, which is hopefully run and is inside the build result, the outcome from that is equal to success, which means the task has running and was successfully and everything is fine. The next thing is we want, if we run the task twice, that it's up to date and the task shouldn't run the second time. But unfortunately, it isn't. Well, we don't have to find any output file yet. So Gradle don't know if the task has to be run again or not. So we have to say, okay, that is the output file, and there we write things in it. We can use that output file annotation, and we can use that at properties or method. If you like, you can also apply it to a method. And we create that file, the project file, create a file somewhere in the project, so you don't have to use an absolute path or something like that. And we want to create that glog directory, the glog text file, in the build directory of the project. And if the task run, we create that file and write hello world in it. So that means if we run it for the second time, it is up to date. Cool, it works. But that's far away from reading lines of code. So to go forward here, you see I can use the project extension container, find my glog block, which I have defined in the apply plugin. It will be returned, and we only want to run if the extension enabled. Then we create the output file based on the DIR's file passes. I've splitted that out because I don't want to show how to read lines of code in a file hierarchy, but I want to show how to write a plugin. So just to see here. But yeah. And finally, we want to print out that the output, which has a task generated, can be found somewhere. So testing, we apply the plugin. We say enable true. We create the we set up the DIR's property with a directory somewhere. We create a test XML file in it and write this is Droidcon Italy Turin in it. So we expect that the output or the text file contain somehow 5. We create the Gradle runner as well with arguments glog to run the task and do the assertions on that the file exists. Well, if the file doesn't exist, the glog file is null. And read the text, and it should contain 5. Cool. The next thing is, if we change the input, so the directories property in the glog extension, we wanted that the task run again, because, well, files in a different directory are completely different. And but for now, it isn't like that. Well, it's up to date, because we don't have defined any input yet. So Gradle knows we have that output, and if the output haven't changed, well, then I haven't run again. So we have to define inputs as well. We can do that like that. We read the glog extensions and map of each string there. And so we have a stable, not stable, input, but that isn't working. Well, because Gradle is too fast here. And the DIR's array is always empty. So it will be always an empty, and it's always up to date. So for that, we have to create a helper task for us. I will show that in a second, which generates us an input directory text file. And that means, okay, it's stable, and Gradle knows when the input file haven't changed and the output haven't changed, then it's up to date, and I don't have to run again. But if the input dir is different to the previous run, then I have to run again. That's a helper task. It defines not a single input and not a single output, and it will always run. Gradle recommends to, or Gradle says you can do such helper task, which will always run and never up to date and such things like that. But such a task should be as quickly as possible. Well, if such a helper task create a APK for us, it's not fast, and yeah, well, it's not a helper anymore. What we do there, if it runs, we create that input directory file, read the extension with the gist property, and put each string into that file. We have to register that as well. We create as well before project task create with the name and the type. This time without the configuration, because well, it's just a helper task for us developers, and no one should run that input task because it has no value to the builds themselves. We have also defined that our real task, which reads the lines of code, should depend on that input task, so that the input file is always up to date if our real task is it's time to run or even not time to run. How a test look like, as well as we've seen before, we define different inputs. The first time the source, the second time another source, and well, both should be succeeded, and well, it works. So that's the skeleton of our task. We have the output file, we have the input file, and we have the task action. From my point of view, and as a really retrofit fan, that are not enough annotations. So I think we have to put it another into it, the cacheable task. The cacheable task just says, okay, that task can be used in the Gradle cache. Otherwise, it isn't cacheable by Gradle. And yeah, that's all. Now our task can be cached by Gradle, either into a local cache, as well in the Gradle home directory, or in a remote cache. How to test that? The same setup as before. This time we create also the settings Gradle to move the build cache somewhere in the temp directory, because Gradle shares the same cache for testing and for your real projects, and it leads to confusing if you don't change the local build cache directory, because everything will be moved into the home directory of Gradle, and then maybe your test will be different, or yeah, behave differently and expect something different. Then we create the Gradle runner, this time with the arguments clock, the task, and build cache enabled. And if we do it for the first time, the task should be run and success. Then we delete our build directory to make sure that the output isn't there anymore, and run the task twice for the second time with build cache enabled true. And then we want to say, okay, it should be used, the output from the cache. And that works. Finally, that's it. There's no more magic in Gradle. To recap everything, what we have done. We have created the project. Well, of course, we created the Gradle files and registered our plugin. That's the thing with the plugin block, where we say ID and implementation class. The next thing was we created the plugin. That's the thing where we implement the plugin interface and the extension and create the tasks. The next thing was we created the extension. Well, it's just the poor old Java class, Kotlin class, with the default values. And finally, we created the task with all that annotations in it. And yeah, that's all. That's all from my talk. I thank you all. Yeah, if you have questions, you can find me here at the Droidcon. I will be available till the end of the day. You can find me at Twitter, or as I said, at Medium. And the source code of that plugin is also available at GitHub. You can find it at stefmark.glog. And yeah, feel free to contribute or create issues or something like that. Thank you.